Alright, now we're going to talk about something called substitution. And the main formula that we're going to use for this is the integral x to the nth dx is x to the n plus 1 over n plus 1 plus c. Okay, so this is an indefinite integral, which is the same as an antiderivative. Now, just some notes or tricks of the trade, if you want to call them that. If I wanted to integrate this integral, you would need to multiply it out because there's no product rule. Then you integrate each one term by term. So that would be the integral of 2x cubed plus x squared minus 6x minus 3. And you would integrate term by term, so that would be x to the 4th over 2 plus x cubed over 3 minus 3x squared minus 3x plus c. So you integrate term by term. You can't just integrate one term and integrate the other term. You can't break them up like that. So that's the deal for multiplication. That term by term. Well, what about if you had a division problem? So with division, if there's one term in the denominator, like x squared plus 1 over x squared, say, we separate it out. And we put the denominator under each term in the numerator, so we're integrating x squared over x squared plus 1 over x squared. So that's the trick here. And then you're integrating this, which is x plus x to the minus 1 divided by negative 1, which is x minus 1 over x plus c. So in that case, you can't just integrate the numerator, integrate the denominator separately. You have to use some, as we call them, tricks of the trade. So the goal of this lecture is to put all other forms, integrals that we'll look at, in the form x and, or actually let's say du to the n du, so we can use the power rule where we add 1 and divide by the exponent. So that's going to be our goal for this discussion, and that's called substitution. So for first example, we want the integral of x squared minus 1 to the 4th 2x dx. Okay. Well, we don't want to multiply that out because that exponent is to the 4th power, and that would be too hard. So, I mean, one way to do this would be to multiply out the whole integral. But if you notice, this is x squared, and this is the derivative of x squared. So what we're going to do is use something called substitution. And the way it works is that the integral of a function within a function, two functions composed with one another, and if you have your derivative on the outside, you can change all of this into f of u du, into this integral here, where u is the function g. So if you have a function inside another function and its derivative on the outside, then we can change it to this function here. In this case, in these cases, it's going to be x to the nth or u to the n. I'm going to change everything to u to the nth. So again, look at what we have. We have a function, and we have its derivative here. So if we have this integral x squared minus 1, that's g of x. So we have g of x to the 4th times g prime of x dx, where g of x is equal to x squared minus 1, and g prime of x is 2x dx. Well, just 2x. That's the derivative. So that's what this changes into, which is really, we could write it as u to the 4th, and this is du. When we integrate it, we get u to the 5th over 5 plus c, so we integrate it. And switch back. U is really g, so that's going to be x squared minus 1 to the 5th over 5 plus c is my final answer. Okay, so going back, let's just go back and look at this again. This is my problem. I let u equal the function inside another function. That's my g function. So pick a function inside the power or root, and that's usually how you pick it, or the denominator. And that's usually how you pick u. Now you might not pick u right the first time, so if it doesn't work, then you have to go back and pick another u. Again, this is trial and error. So then when we take the derivative, that should be sitting outside here, 2x dx. So this integral changes to u to the 4th du. And that's the power rule. So that's the point in all of these problems. Okay, like I want the integral x over the square root of x squared plus 2. Alright, I pick this to be u, because it's inside the square root. I always pick u to be the highest power of x, the term with the highest power of x. So let's try x squared plus 2. I don't pick it with the square root, I pick it inside. The function u is an inside function. So I don't take the square root with it because that's inside the square root. Then du is 2x dx. So that's what I do first. Pick a u and take its derivative. Well, look what I have right here. I have an x dx, and that's right here. So what I can do is bring this 2 over and make this substitution. Instead of x dx there, I'm going to write 1/2 du, and on the bottom is going to be the square root of u. That's what this is. So I substitute in the du and I substitute in the u. So what I'm integrating is 1/2 u to the negative 1/2 du, and I add 1 and divide by the power and replace u with x. U really is x squared plus 2, or square root of x squared plus 2 plus c. So again, I pick u to be the term with the highest power of x. Okay, let's try another one. Or I pick u to be the power inside the function, or the expression inside another function. Okay, so this is an x squared and this is an x, so let's u be inside the root. Then I take the derivative immediately and see that it's 2x minus 1 dx, which is what I have right here. And this is what I have right here. So the u is what I have right here. So far I have u to the 1/4 du is u to the 5/4 divided by 5/4 plus c, which is 4/5 u to the 5/4. And then I substitute back in x. Okay, so that's our final answer for that problem. So hopefully you see how substitution is working for us. And let's try the trig functions. We have integral x squared sine x cubed plus 1 dx. So again, we pick the function inside a function, so our sine is the f function. Pick g of x or u to be the inside function, so that the derivative of x cubed is 3x squared. You see the derivative is going to be out here along with the dx. So our f function is the sine, and that tells us we should pick u to be the inside function, which is x cubed plus 1. The derivative of that is 3x squared dx. I only need the x squared dx, so I divide both sides by 3, bring the 3 over. Okay, so the x squared dx is going to get replaced by the 1/3 du. And I have sine, and this is my u. So I've changed this into just a plain old sine u integral, which is negative cosine u plus c. So when you do this, suppose you just have like a constant and an x inside the sine. If u is that constant x, then du is just the constant, and we divide by the constant and get the dx, so that changes it to sine u du, which is going to be minus cosine u, which is the 1/k, I forgot, plus c. So, and then you change it back to x. But let me write down these formulas because these are really important. So if I have a sine of a constant, that's just going to be cosine divided by that constant, negative cosine. And if I have cosine with a constant x, then that's just going to be 1/k sine kx. So if you want to remember those would be convenient to remember. Okay, the next thing we're going to talk about is those were indefinite. These are definite integrals. With definite integrals, you change your limits also. So it's a nice way to integrate this. It's going to be g of a, g of b, f of u du, where u is g of x and du is g prime of x dx. And see right here, let's make this change. If x is equal to a, then g of x is g of a, and that's going to be our u. So we need to change our limits by substituting our lower and upper limits into the inside function, or the u function. So let me do an example of that. I want the integral of say minus 2 to 1 square root of 2 minus x dx. So here u is the inside function. My du is minus 1 dx. So negative du is dx. And so what I do with this, I take my lower limit and I substitute it in for u. So that's going to be 2 minus a negative 2. And I take my upper limit and I substitute it in for u. See, because back here these were x values and everything was in terms of x. Here these are u values and everything's going to be in terms of u. So when I substitute in 1, I get 2 minus 1, u to the 1/2 minus du. So the negative comes in front. I'm going to do 4 to 1, u to the 1/2 du. And I can switch my limits. I usually like the lower one on the bottom. When I switch that, the negative disappears. So the rule is when you switch your limits, you add a negative sign. And I add 1 and divide by the exponent. I don't need that because this is an indefinite integral. So that's going to be 2/3, 4 to the 3/2 minus 1, which is 2/3. The square root of 4 is 2. 2 to the 3rd is 8. 8 minus 1 is 7. So this is 14/3. Remember, with a definite integral, you get a number answer. Okay, there's one more thing I want to point out in this section, which is really important, and that's having to do with symmetric functions. If my function is even, that means f of x is equal to f of negative x. The integral of negative a to a of x dx is twice the integral from 0 to a f of x dx. If you look at a picture, this should make sense. Even means symmetric across the x or the y-axis. We don't do symmetry across the x-axis. It's not a function. So this is negative a to a. So instead of going from negative a to a, we'll just go from 0 to a and integrate this and then multiply it twice. There's 2 of those humps. So if it's even, you're just going to go from 0 to a and multiply it by 2. Okay, we use that a lot. If f is odd, that means f of x is negative f of negative x, then negative a to a. Again, that's symmetric. See, it only works when the a's are you're going equal distance on either side of 0. That's going to be 0. Because they're going to cancel out. If you do an odd function, this is symmetric across the origin. So this right here is going to cancel out this area here, negative area, so they're going to cancel out and give you 0. Okay, so that's a really important fact. Watch for that when you do your homework.